Welcome to our Instructor Training Center Scaling Networks class for the week of 10/19/17. We appreciate, or I appreciate, it's not we, it's just one of me, I appreciate you being here for class, and we're going to start out with a couple things. First off, I do want to mention that while grading the items for Chapter 3, I've noticed in the packet tracers for Chapter 3, there are several where you have to set, like switch 1 is the primary for VLAN 110, 30, 50, etc. And then switch 3 is the primary route for VLANs 20, 40, 60, 80. Well, even using the correct commands, in other words, spanning tree, VLAN 110, 30, 40, whatever, route primary, using the correct commands, the packet tracers are not giving you the points. So I think that there must be a grading error there, or it's trying to want you to just put in a priority number, which is kind of nuts because the actual packet tracer says to set it as root and secondary, so primary and secondary. So they're really trying to tell you to use the primary and secondary root commands, but then they're grading you based on something else. So just want to make you be aware of that. If you do a show spanning tree and you have the correct information, in other words, S1 is the root in spanning tree for the correct VLANs, and S3 is the root for the correct VLANs, and don't worry about not getting those points. So it's like 10 points, I think, on two of the different packet tracers. So, all right, today we're going to start off talking about two items. We've got Ether channel and HSRP, both really dealing kind of with high availability because Ether channel is going to allow you to aggregate links. And we're going to talk first about what would happen. We learned spanning tree last chapter. So you know if you put in multiple links between two switches, those links will have spanning tree run on them. And in order to prevent a loop, one side will be blocked. So even though you've got two physical links in this example here that we're showing, spanning tree would cause one of the links to have a blocked side and a forwarding side on the opposite side. And that's just to ensure there's no loop. We could have a broadcast storm at layer 2. It would be nice, though, if we could take and use multiple links and aggregate that bandwidth into a single link, so a single virtual link. And what we can do is we can use a protocol called Ether channel, or a process called Ether channel, and there's two protocols we're going to use to set these up. But it's a process called Ether channel. It was originally developed by Cisco so that you could take these links and aggregate them together so that they appear as one faster link. The beauty is a single link in the Ether channel can go down and the Ether channel will stay up. You'll notice this is just two links, so that would be still be a problem. There's no redundancy if one of them goes down. Well, there's one point of redundancy, but no increased bandwidth if just one goes down. But depending on the model of Cisco switch, you can aggregate up to 6 by default, and even more depending on what the model number is, up to 6 different links. So instead of having a 1 gigabit link between your core and distribution area, you can actually do 6 gigabit send, 6 gigabit receive, because they are designed to be used in full duplex. So it's pretty easy. We'll show you how it can be done. That there is the ability to do load balancing based upon IP addressing, MAC addressing, those types of things across the multiple links. It is seen as one logical link, so you don't have to worry about spanning tree blocking one of these links. Now, spanning tree does run on the links as one link. So if there was a set of links between the switch on the left and the one on the right, you would have a link there, and one of these would be blocked, so there would not be a layer 2 loop. But to the switches, these two 1 gigabit links appear as one port channel, which is an Ether channel that we have put together. Any questions on that? There's some requirements to make sure that you can actually put ports in the port channels, but we'll go over those in a second. But any questions about how this is just an aggregation of the physical links? None? Okay. Pretty simple concept. Some of the restrictions. Number one, the ports must be the same speed. The ports must have the same duplex settings. The ports must be set the same in terms of either an access port or a trunk port on all the ports that are involved and on both sides. And the trunk ports, if they limit the VLANs that can travel across them, must have the same VLANs allowed. You can see here, You can do 8 gigs. This is an example of 6. You've got 6 gigs in, 6 gig received. So you've got all these physical ports put together to create one logical port channel interface. Now, obviously they're saying 6 ports. Again, take that with a grain of salt because it depends on the iOS you have, and it also depends on the switch that you have. So different types of switches support different numbers of physical ports in a logical port channel. The beauty of this is that redundancy, the speed, the ability to increase our links. Now, here's the great thing too. These are considered to be layer 3 port channel or layer 2 port channels. We don't talk about layer 3 port channels in this class, but those are possible with multi-layer switches. Also, as you move on up and look at other switches, you can port channel 10 gig links so that you've got a 20 gig send, 20 gig receive, and even higher than that. So I want to actually run forward real quick and go to this particular item before we talk about the protocols that can be run across a port channel. First off, in order for an Ether channel to be formed, they have to be Ethernet. That seems like common sense, but that has to be. The speed and the duplex must be the same on both sides. So 1 gig full, no problem. They must be in the same VLAN if they are not a trunk port. And if they are a trunk port, you must have the same VLANs allowed on both sides. So the switch port trunk allowed VLAN command, that command must allow the same VLANs on both sides. So this, you could form an Ether channel because all those parameters match. This will not form an Ether channel because one side is half duplex, the other side is full. So be aware of that. These items here will show up somewhere again. So I'll just tell you that. You will see that somewhere in the future. Now let's talk about our 2 protocols that we can use to run a port channel. And you don't have to run a port channel. You can just turn a port channel on. But if you want, you can actually do what's one of these protocols, the port aggregation protocol, which is a Cisco proprietary protocol that will aid in the automatic creation of the Ether channel links. And what we do is we set each side to a particular mode, either desirable or auto or on. On just means it's on, there's no negotiation, it's going to be a port channel. The desirable is actively asking the other side to be a port channel. In other words, it's sending out page P, and that's how we pronounce it, page P. It sends out page P information, says, I want to become a channel, I want to become a channel on these 2 ports, will you become a channel? If the opposite side is set to desirable or if it's set to auto, okay, it will become a port channel. If the other side is set to just on, it will not become a port channel because it will ignore. It's not going to actively negotiate, and it won't negotiate because it's just on. If both sides are set to auto, this is kind of like my wife and me today trying to figure out where we're going to go eat lunch. I said, well, I don't care. Where do you want to go? No, where do you want to go? Where do you want to go? Basically with this, the 2 sides are sitting waiting for the other side to make a decision. Now, one of the ways I remember this and try to remember this is auto and desirable. Page P is auto and it's desirable. And I'll show you how it's easier for me to learn like P and remember it than it is page P, and then I kind of know the difference after that. But know how this works. If it's on and on, you've got an Ether channel. If it's auto desirable and the other side is desirable, okay, so either one of those, you get an Ether channel. If it's on auto desirable and not configured, you get nothing. So it's not like GTP. There's no page P or Ether channel protocol running by default. If it's on and desirable, you get nothing, and that is because this is the one that's a little confusing, because this side is requesting to become an Ether channel with page P, but this side is just on. It's not listening to or sending page P information, so you do not get a channel. And then auto on and auto on doesn't because they don't even begin the process. You'll notice that page P sends every 30 seconds, checks for consistency, checks for whether or not the links are up and what links are in the channel. The beauty of it is this is super simple because the next one is LACP, and LACP is a open specification. It has 3 modes also. On, which means it's on with no negotiation. It will be a channel. And then active, passive. And active is actively seeking to become a port channel, all right, or an ether channel. Passive is waiting on the other side. You can remember the 2 modes of LACP because the initials are in LACP, active and passive. Then you know the other one's auto and desirable because it's not active or passive. So if one side is active, passive, or passive, and the other side is active, then you're going to get an ether channel. If you're on, active, or passive, and the other side's not configured, you get nothing, just like in PageSpeed. If it's on and active on here, you get nothing. And again, this is where one side is sending LACP information and saying, I want to become an ether channel, but this side's on and saying, no, I'm already an ether channel, I'm not going to talk with you, don't need to. And passive, just like auto, it sits there and says, well, I don't really know, what do you want to do? Do you want to become a channel? No, I don't want to become a channel. Basically, honestly, it's just listening and not doing anything at all. LACP does allow for 8 active links and 8 standby links, and that would allow it to come up. And then that, right now, for what we're doing in Cisco CCNA, that exceeds what our switches will support. Now, the beauty is these are extremely easy to configure. I mean, extremely easy. So, if you want to do a LACP port channel, you do an interface range and pick all of the interfaces you want to be part of that LACP. You do channel group 1 mode and then active or passive, depending on what you want to do. Okay, remember, this is LACP, which is active and passive. So as long as you get a mode that will bring a channel up, so you're doing active on one side, passive on the other, or active, active. You then go into the port channel because it automatically creates a port channel. And then you go in to make that port channel either an access port or a trunk. In this case, it's a trunk. Switch port mode trunk. Switch port trunk allowed VLAN 122 and 20. You would then have to go over to S2 and do the same exact thing. So in other words, here's the thing you've got to be careful with. You've got to make sure it's part of the same channel group. Okay? So channel group 1 is used on S1 side. Channel group 1 has to be used on the S2 side. Let me show you an example of this. If we look in our NetLabs, this is our lab that we're going to do. I'm going to set up I'll start out here on switch 1. And I'm going to go config T. I'll give it a name. Let me do this first because I always line con 0. Login synchronous, that way I won't have to worry about stuff jumping over. Host S1, and I'm going to say interface range FA01-2. Okay, now I'm going to go channel group, and then notice it says some number between 1 and 6, so it supports up to 6. Channel group 1, and then you can do mode, and you'll notice it then lists all your mode: active, auto, desirable, on, and passive. So we're going to do a LACP. So I'll make this side active. It's going to create my port channel. Then I'm going to go to interface port channel 1. I'm going to do switch port mode trunk. Now that's all I really have to do. I don't have to go in and do anything else in terms of, I don't have to do allowed VLANs if I don't want to. I'm now going to go over to switch 2. All right, and config T, host name S2, host S2. That color is very hard to see, so I'm going to change that. All right, it's the same as S2, but it's easier to read. Then we got interface range FA01-2, channel group 1 mode active, int port. And of course I didn't do it on this. I didn't do my line logging synchronous. Notice the difference with logging synchronous, how it automatically returns down so that you don't have this junk in on your command line. Interface port dash channel 1. And I'm going to do switch port mode trunk. Okay. And do right. And I'm going to go line con 0. Logging asynchronous, so I get rid of that, and then do write it again. Okay. Which is just short for copy run start. So now what I'm going to do is I can go over here and on switch 1, do a show ether channel. Okay. You'll see I've got group L2, ports 2, max port 16, LACP. I can also do show int port channel. Oops, not a 1. And show me the port channel and that it's up, connected. And I can also do show ether channel summary. And this shows you that you've got a port channel interface of group of 1. You got 1 port channel, it's using LACP, and you've got 2 ports in it. Likewise over here, if I do a show ether channel summary, which is my favorite command to use, you can see I've got ports 0, 1, 0, 2 in a port channel, and they are bundled in the port channel. I like these. So this shows that I just created a dual link between S1 and S2 that is using 2 ports. The only difference between this and PHP is just the commands you put in. Instead of putting in the commands active or passive for LACP, you would put in auto and desirable. So it's a very simple thing to do. But it is extremely important because it gives you that aggregation that you need. You're going to do labs that allow you to do both. Okay, and that's it for that's ether channel. I mean, you've got this command here, verifying it, show interface port channel 1 to prove that it's up, and that proves it's actually running. You've got show ether channel summary, which is my favorite command because it actually shows you your groups, the port channel numbers. You know, see here, SU tells you it's a layer 2 and in use, so that means it's up. LACP, and then tells you the ports that are in it. Show ether channel port summary will show you the group, and it will also show you information about what protocol is in use and the ports that are in that, so it's a little more detailed and shows you the load. That's one of the neat things about show ether channel port summary. It will show you the load. So let's show that one on. As you can see, this is a LACP group 1, and it shows you the load. And obviously, I have 0 load right now because nothing at all is going across this link. Show interface F01 ether channel will show you the actual channel group that particular port is in. Okay, what port channel it's associated with, its mode, and the protocol it's using. And then goes on to show you the priority and other items that if you need more detailed information about the port itself. And that's really all the commands. 99% of the problems you can fix with this command right here. It shows the channel summary because you'll see whether or not you're in the correct group and what ports are in the group and what protocol they're running. Common errors are one side running LACP, one side running PHP, or one side trying to do auto configuration and the other side is set to on or something of that nature. Here we can see a down ether channel. So show ether channel summary, you see this is down. So you can go and look and make sure that the ports, if they are access ports, they're assigned to the correct VLANs. If they are not trunking on one side, that would cause this problem. And the incorrect range of VLANs would cause an issue. So see, try to do mode 1, mode on, desirable, desirable. This is an example of one side being set to be on automatically and one side set to try to negotiate. And this will never become an ether channel because the switch 1 side will not talk PHP to switch 2. And so here we just go in and change it, okay, and you can see it comes up. So in other words, they went in and made on port 1 desirable to make that a PHP, and both sides are desirable, and when you do that, the port channel comes up. Don't confuse these two with DTP. Okay. These two aggregate links. Okay. So PHP and LACP aggregate links. Dynamic trunking protocol creates links, trunking links automatically. So very different for what they do. Any questions on Ether channel? Because that's it on Ether channel. It's super simple. Welcome, Larry. Glad you could join us.
Thank you. Sorry I'm late.
That's okay. I understand completely. I understand. So you've got a couple labs on that. Now, let's move on to our next item that we're going to look at for redundancy on our networks, and that is the concept that a PC can only have one default gateway. If you look at this network right here, we've got two access layer switches and two distribution layer switches. We have redundant links. We should be able to, if this link up to this R1, this multi-layer switch fails, we should be able to go over to R2 and go out. But because of the way 99% of all operating systems work, that's not possible because you would have to go in and manually change the default gateway on PC1 because it can only have one gateway set. This can be fixed by a first hop redundancy protocol, FHRP. And what that is a protocol that is going to allow you to, that is serviced by, have passed out of the network. So in our case right here, this router and this router, there would be a virtual IP that is used as the default gateway for PC1. And that's what this is. Here's a virtual router. It's just an IP address that both of these routers are servicing, that all the PCs on the LAN send their information to as the default gateway. With a first hop redundancy protocol, if this router goes down, this other standby router can start forwarding packets or forwarding information because it's also listening for anything coming to the virtual MAC address of this router. The forwarding router will forward until it fails, then standby takes over. And there's a process that these two routers are sending hellos between one another so that standby router knows the forwarding router is up and running. Standby router, if it stops seeing hello messages from the forwarding router, it will become the forwarding router. Then what will happen when the old forwarding router comes back online depends on how you have the system set up. By default, it will not take back over as the forwarding router unless you have a special command which is called the preempt command that we will talk about when we discuss HSRP. Now there are multiple different first hop redundancy protocols. The one we're going to deal with is HSRP, or the Hot Standby Routing Protocol, version 1 and version 2, that are part of the Cisco IOS and is proprietary. There are others, however. There's VRRP version 2, which is an open standard, and VRRP version 3. There's also GLBP, which is a Cisco proprietary protocol that will actually do load balancing in addition to first hop redundancy protocol duties. So these, HSRP and VRRP, do not do any type of load balancing. GLBP will do load balancing. There's also another one down here, ICMP Router Discovery Protocol, and it's a legacy protocol that used to be used where if a PC saw that its gateway failed, it could go out and advertise to try to find or send a solicitation message to get another router gateway out of their network. It's not really used a great deal anymore, so we kind of just skip that over. But I would know HSRP is Cisco proprietary, GLBP is proprietary and does load balancing, and VRRP is a first hop redundancy protocol that is an open standard. So, and they got you to do this. The Cisco proprietary allows for load sharing. You know, that's going to be GLBP. Used in a group of routers for active and standby. That's going to be HSRP, and then we go on down and do these. I'm just going to tell them I got them wrong. Got the first two right, but I'll let you do the rest of these. So what is HSRP? Hot Standby Routing Protocol lets you create a virtual router IP address. It also creates a virtual MAC address, and that particular virtual router is serviced by both the forwarding and the standby router. In other words, both the forwarding and standby router listen to any traffic coming to this address and will forward it appropriately. They will also exchange HSRP messages to ensure that the forwarding router is up and that the standby router does not need to come online. HSRP v2, the big changes are it supports more groups. It uses a different multicast address. HSRP v1 sends out its hellos to 224.0.0.2. HSRP2 uses 224.0.0.102 and FF02:66. I don't think you need to remember that, but HSRP version 1 and 2 use different MAC address ranges. And HSRP2 does support MD5 authentication, which is very important. We don't go over it in this course, but it lets the two standby and forwarding router actually authenticate one another. For us, we're going to do very simple HSRP configurations. When we do this, when we set up an HSRP group or an HSRP setup, one of the items that's very important is priority. You may want this router, R1, to be your forwarding router and R2 to be your standby to begin with. If you're going to do that, you must go into R1 and set the HSRP priority to something higher than 100. You would also want R1 to boot up first, because what will happen unless you have this preempt, which is done with a simple standby preempt command. If you don't have preempt, the first router that becomes active will be the active router. So, in other words, even if I set the priority different on R1 and make the priority 200, if R2 boots first in the HSRP group and it boots up, it will become the forwarding router. And without preempt, R1 will not become the forwarding router until R2 goes down. So it's important that you set preemption on the router that you want to be your primary forwarding router. I'll show you how to do that. It's very simple. Here's a couple states and timers. You don't have to learn these, every bit of this, but basically, in the initial state, they're first becoming part of the group, HSRP group. They're going to learn the virtual IP address, and they're going to actually learn to see what other routers are in the HSRP group. And then they know virtual router, learn the virtual IP address, and then they can speak, so they send out the hello messages. And then you're either going to be standby or active, depending upon what mode and your priority. Now, notice the standby router will become active if it doesn't receive a hello message after 10 seconds. You can lower that, but that's the default. And HSRP routers send hello packets every 3 seconds by default. So there's a good amount of traffic going across the HSRP. It is very simple to configure except for one item I want you to be aware of. Be aware that when we set up HSRP, we're going to set it up on the interface, okay, where we want to have the shared virtual router. So we're going to set it up on this internal gigabit or fast Ethernet interface. This will be gigabit for R1 and R2. But that's important because when you look at the commands, you need to see there are interface commands. So if I go in that gig 01 and put standby version 2, that means it's going to be running HSRP v2. Standby group number, all right. And then you want to put a group number of 1, whatever your group number is, put that in there, and then the IP address you want to use. So you have to put in the virtual IP address for the group, and then you can set your priority, standby 1, and then priority value of anything from 0 to 255. Higher is better. And then you can do standby 1 preempt if you want this router to preempt. On the other side, you would put standby version 2, standby group number, the same IP address, because remember they're servicing the same virtual IP address. I'd leave its priority alone, and you wouldn't put preempt on it. So when you go in here and look at the configuration for this, you go into R1 in the gig 01. You put a regular normal IP address on it. Does have to have its normal IP address. Then you put standby version 2, standby group number 1 IP. This is going to be the default gateway for all the PCs on our LAN. Put our priority in of 150 and put in preempt. On R2, put in its IP address, standby version 2. Make sure it's sharing the same virtual IP address. Okay. Then no shutdown, and when that happens, R1 will become the forwarding router, and R2 will become a standby router in HSRP. How can we verify this? Simple command, show standby. It will give you what the state is. It will tell you what the virtual IP and virtual MAC address is. It will tell you what the hello and hold time is. It will tell you whether or not preemption is enabled, and it will even tell you what the standby router's local IP address is, its actual IP address, and priority. Okay, that's its priority by default, and then configured priority. Same thing on R2, shows this is the standby router, sharing the same IP address and MAC address, and that its priority is just the default.
On that hold time, I'm just trying to understand. You've got a hello every 3 seconds, and there's a hold time of 10 seconds. It
Right.
takes 10 seconds to do?
No. So let's imagine hello's most of the time you find in Cisco iOS, the hold time is 3 times the hello interval. So, and I know 10 seconds is slightly above that, but every 3 seconds you send out hellos. If the standby router does not receive a hello after 10 seconds, in other words, if there are 3 successively missed hellos, then the standby router transitions to forwarding. Does that make sense?
Transitions to forwarding.
Right.
No.
All right, so imagine this. Right now in our setup, with the way this is set up, we know that the state is active on R1. So right now, if this PC sends anything to its default gateway, and this PC actually has its default gateway configured to be 172.16.10.1, okay? So if it sends something to its default gateway, it's going to come up, go into switch, and it's going to actually go to both, okay? It's going to go to MAC address. It's going to come up here, and then R1 is going to grab it, and R1 is going to send it out, because this is the active router. This is the one that is currently forwarding. R2 is not forwarding because it is not the active router in the HSRP group. If R1 goes down, okay? So in other words, during this whole time they're sitting here, every 3 seconds R1 is sending a hello packet over to R2 saying, I'm here, I'm here, I'm here. But let's say this link goes down right here, and 10 seconds pass without R2 hearing a hello packet from R1. R2 will then become the active router, and traffic that comes to it, it will then forward. Whereas before, it was in standby mode, and it was not forwarding.
Okay, but that's within 10 seconds. What's the 40 seconds? Did you say 40 seconds or 10 seconds?
10 seconds. I said 10.
Okay. I thought I heard 40 seconds.
I may have screwed up, but I think I said 10 seconds.
Okay.
It sends a hello every 3 seconds, and the hold time is 10, which is 3 times the hello.
Okay.
And I may have messed up, John. If I did, I apologize, but it's the hold time is 10 seconds.
Okay.
Sorry about that if I did mess
I'll have to
up.
review again.
There's a possibility I did, but basically how it comes down to is after the standby router misses 3 hellos from its neighbor, from its active router, then it's going to go active.
Okay.
So now sometimes you may want it to be faster than that, than 10 seconds, but you would have to change that. This shows you standby brief, and it shows that we'll have this is gig 01 is active and it will preempt. Here, show standby brief on R2. It's gig 01 is in standby. Now, and it shows you the active router is 10.2, which is over on R1. This is important though. You need to make sure and always that the virtual IP address is the same on both sides. Otherwise, it's not going to work. That's actually one of the common errors with HSRP. So when there's a failure, there can be a failure to elect the active router, failure of the standby router to keep track of the active router, and that's usually a problem with timers or group numbers. And then the IP address being wrong for the virtual. We can debug standby, and you can debug errors, events, packets, or a limited range of errors. And terse, should be figure 4. I'll show you what terse does. So R1 is powered off, debug standby terse, and it shows you active timer expired, active router is local, was this. This shows it becoming the active router. So it went from standby to active, and this is showing R2 when R1 is powered off, becoming the active router. Debug standby packets, this shows you all the hello packets every 3 seconds. So group 1 coming from 10.2 active to 10 active 4 10.1. That's what I just showed you. Here's an example of group to become an active HSRP member. So R1 comes back online, and then it goes through and tries to become, it preempts. This is where it comes in and says, hey, look, I'm gonna have a coup here. I'm the one that has a higher priority. So even though I'm offline and I was going to be the standby router, when I come back online, I'm now going to be the active router. And what it will do is it will eventually force it to become active. So it goes through and become the active router. So, and that's what the preempt does. Standby 1 preempt would allow R1, if it went offline, when it come back online, to take back over as the active router. You'll learn later about there are ways to actually track outside interfaces and then use that, because right now we're only, this link would have to fail for HSRP to take over. This link, if it fails, it wouldn't affect this HSRP, but there are ways to actually track this link and make it HSRP drop if the outside link goes down. Outside the scope of this course. So we see it again, just showing the different debug commands. So showing one go active from passive or standby to active, not passive, standby to active. And that's it, folks, for the Ether channel and HSRP labs, or Ether channel and HSRP sections. These 2 sections are fairly new on the Cisco CCNA, so they're something you need to know how to do. They're big topics in the data center, especially Ether channel, so it's something you want to be able to do. Make sure you do the hands-on labs for these particular chapters and at least 1 or 2 of the packet tracers. They're good labs, they work well, and I think you will actually enjoy them because they're kind of neat to show. Don't forget the 3 different types of first hop redundancy protocols: HSRP, which is Cisco proprietary, VRRP, which is not Cisco proprietary, and GLBP, which is Cisco proprietary but provides load balancing across the multiple links in the Ether channel. Are there any questions about Chapter 4? Okay, very good question, Scotty. And the question is, what would be the advantage of HSRP over VLANs? The problem with VLANs is, let's go back. Okay, now we're getting into a little more complicated setup here, but you could actually do the following. VLANs are separate from HSRP, but you can do HSRP for VLANs. And the way you would do that, let's imagine, man, I wish I had my tablet where I could actually draw on here. Let's imagine that you had 2 VLANs. Let's say you had, let me pull me up the notepad. Okay. Let's imagine in this diagram right here that you had VLAN 10 and you had VLAN 20, okay? And let's say that VLAN 10 is the network 192.168.10.0/24. And VLAN 20, let me tab this over so we got a little room, is 192.168.20.0/24, okay? What we could actually do here is we would have to create 2 routers on a stick. So in other words, we would make this a trunk link with sub-interfaces, and we would create a sub-interface on R1, or 2 sub-interfaces on R1, that would be the following. You'd have you'd have GI, let's say GI 0/1 0, I can't type, 0/1.10, and you would put the IP address 192.168.10.2/24. And then you'd have GI 0/1.20, and you'd put 192.168.20.2. You would then, on this opposite side, do the exact same thing. I'm going to pull this up and out of the way here. You do the exact same thing with R2. So you would create, on R2, a series of trunks that have these same items mapped with the same VLANs. Okay? But you put 10.3 and 23, 20.3, okay? Both /24. You could then run HSRP for this network using 192.168.10.1 as your virtual IP address, and this network using 192.168.20.1 as the virtual address, and just set these 2 up to be in the HSRP group. You'd have an HSRP group for this, and HSRP group for this. So honestly, you can't say that VLANs are an advantage either way, because VLANs don't allow first hop redundancy protocols. All VLANs do are split you into multiple networks. What HSRP lets you do is let you have multiple ways out of the network, but only give the clients a single gateway. So you set right here, and this PC could be in VLAN 10 and this one in VLAN 10, and their their particular gateway would be 192.168.10.1, and either one, R1 or R2, could service that. Same thing, exactly, redundancy. That's all it's for, is to give you a redundant gateway, and it's really just a gateway that's served by redundant routers, and that's it. All right. Great question, though. Very, very good. Now, this is something I'm actually thinking about having students doing some contests, because I want a way to be able to do multiple internal VLANs and still have HSRP. So I'm looking forward to actually doing this and playing with it, because I know it works. I've done it, but it's a neat concept. All right. Any other questions? All right. I'm going to stop sharing my screen then. I'm going to stop the recording. And now you can ask all your questions.